Hey, welcome back to the channel. Good to see you again. Thanks for joining. Hope you're all well. Today on the bench I'm going to attempt a repair on this 1989 BMW climate control on an E34 series car. Now, the problem with this one is the fan's stuck on high, so let's start it up and I'll show you. So it doesn't matter, control settings, set for 0, it doesn't shut off, it's set to cold. This button doesn't light up, that button doesn't light up. I think the control unit is pooched, so we're going to attempt repairing this, get it working again. BMW's climate control for this year and for these cars are very complex, so we're going to dive deep into it. First thing I want to do is pull out the N2 module. That is one that controls the blower fan, and it's basically just a relay, and then we're going to check and see if that thing is maybe shot. So the N module is hiding in behind this panel. Back up here. Now this carpet has to come off. I think there's a screw here, and I think there's one back. I might have to remove the glove box as well, because open the glove box and I don't know, you can't really see, but no, maybe there's no screw up there. Okay, the module's just up here. I think it actually just snaps into place, if I can remember correctly. There's two modules here, maybe. I can slide it back and forth. Let's see if I can get it unlatched. I'm gonna put the camera down. Okay, I remember this now. You have to pull back on these black locks, pull them back out of the connector, and then you can remove the connector. If the black is locked in like this one is, you'll pull all day and you'll never get it out. So you have to back this off like that, and pull that out, and then you can pull the connector. Two connectors, and then you get your hand up in there, stick your thumb over on the top side of it. You'll feel a piece of plastic. See, I'm flicking it right now. If you squeeze it, you should be able to pull the module right out. But now I'm hitting something here. I think I gotta remove the glove box because it's right in the way. So I removed the, what is this called? The IHKA module. This is climate control, heating and climate control. Got connectors on both ends. So this is the end on the passenger side, or right hand side, and this was the one on the driver's side or left. So, and what I did is I test the car, the module's out, so I turned the car on. Fan is still on high, so that tells me that other module is locked up or shorted. Okay, so on the BMW with the fan controller is called the sword, and it's two screws, one here and one here on the top and bottom, and once you remove those screws you can pull the sword out, and it's you have to remove the glove box and everything. And this green connector, that's the motor connector and power. Pull that off, and then you can pull the sword out, and you can see it's quite large, and it comes out as one piece. Alright, so what's your options if you have one of these and it's buggered and you got to replace it? Otherwise your heater won't work in your car. So eBay has some. They're all pre-owned. They don't call them used anymore, they're pre-owned. And look at the price they're going for, $360 some. This one's cheaper, $271, and this is Canadian dollars. Let's have a look at this one. $200 US. And yeah, it looks clean and everything, but I don't know. Looks like they took it from an auto wrecker and he's just reselling it. Same thing, $270 US. That's robbery, if you ask me. It looks a really nice shape. It looks like it hasn't been used much. Looks all original. Let's go look on German eBay, because sometimes they have good prices on German car parts. Holy, 503 euros. Grischbett, that's used, I think. Grischbett. Gebracht. I can't speak German. I'm not even going to try. This one looks used. 500 euros. No thanks. Let's take another look at another one here. 206 euros. Refurbished. I don't know what that means. Refurbished. 250 euros. 250 euros. This one is the same one we looked at. Here's one. New old stock. 1,000 euros. You gotta be kidding me. So I think it pays to fix your old one and save your dollars, money for something else. Look at the prices on these things. And these ones are reconditioned, but you have to exchange your old one. And I think they say right here in the let's see here. Yeah, you must send your old one in before you can buy this one. So, yeah, a lot of money to be had making these things, fixing these things up. So we're going to fix the one I have. Okay, so here's a look at the sword removed from the car. It is a big aluminum plate that is kind of formed into like a wing shape. It's airflow. It has 4 devices, 1, 2, 3, 4, hidden underneath this printed circuit board. And the printed circuit board acts like an electrical connection. So we have, looks like 4 devices in parallel. And then we have, here, let's take the screws out. Let's look at this little circuit here. Little circuit here. There's a connector. And we have a little LM2903, looks like an op amp, and a couple 3 capacitors, 85C capacitors. Look like they're, be interested in checking those to see how badly they are. A couple of 0.47s and a relay. Looks like it's working. Some resistors, support components. There's also a temperature sensor here. This bolt is the bolt end of the temperature sensor. You can see it underneath there. It's 2 legs are going up to the board. There's also a resistor here. So what we have is this trace here, high current. They got a wire jumper from here to this pin. I don't know if you can see that. And then it goes to this trace. This goes to each transistor. And then there's a return path or supply path, whatever you want to call it, on each transistor. And then it goes to this thing here, which is a big high current resistor. It's a chunk of wire. It looks like about 5 or 6 inches long, and it's kind of folded up and crinkled in here. So between this point and this point, we should have open transistor junctions. Let's check it. Okay, so between here and here, I got conformal coating to get through. Hang on, I got to scratch my way down. There we go, and it's a dead short. So one of those 4 devices is shorted. Let's have a look. And pry this one off. And it's just a blob of epoxy, hard epoxy, and it covers up the connections for that device. Let's do this for all 4. Oh, this one's tough. Doesn't want, oh, there we go. Just got to get under a corner and lift it. So you can see the two pins, the center pin. I don't know if this is a transistor, then that would be the collector. And then the emitter is on this side, and then the base goes to a resistor, a small resistor, and it looks like to be, I can't read the value. I can't read the value right now. We could measure it, I guess. Well, we'll do it after we get these uncapped. Let's uncap this one. Wow. And everything's conformal coated for longevity, but it also makes it hard to service. There we go. Okay. Don't look, those solder joints don't look great. Anyways, let's what we're going to need to do is we're going to need to separate the heatsink from the transistors. So I propose to drill out these 4 rivets, and that will release the board from the transistors. We'll still need to desolder these 12 connections. So let me get on that. I'll drill those out and we'll desolder those and we'll figure out what's going on with this. Okay, so I drilled out the 4 rivets on this side, and I also drilled out the 4 rivets on this side. You have to be very careful because this side, once you break through the rivet, you're into the fiberglass and copper, and it goes, your bit just goes right through, so you got to be careful. I think I've got this to the point where I can pry off. We still have to deal with this temperature sensor here, so let's try and get that right now. I'll just take the nut off, see if I might have to back it up with a, oh no, it's coming. Okay, I'll take this nut off. It's a self-locking nut, and that should disconnect that, so we should be able to pry this. Well, the epoxy's holding, that's the problem. Okay, I can see that this is going to be difficult. Okay, just try not to damage the fiberglass. The devices themselves I can replace, so I'm not worried about that. So I'm just going to pry on each one and pop them free. Looks like, ooh, that one, the pins came out of the, okay, there we go. So yeah, that's the danger of this. We're gonna get right into it and pull the pins right out of the printed circuit board, just like so. There's the back side of the board and all our devices. So these are, what are these things? These are MOSFETs. Drain, source, gate. Gate, drain, source. And they're, let's see what we can get a part number off these. BUZ, what is it? BUZ 714? No, BUZ 71A. BUZ 71A. Let's go look those up. Alright, so the BUZ 71A is an N-channel 50 volt 13 amp MOSFET S-trip FET. What does that mean? I don't know what that is. Power MOSFET. And it boasts a RDS on of less than 100 milliohms. So here we go. RDS on is less than 120 milliohms. Current of the drain is 13 amps. So this is late 1980s technology. Now they've come a long way since 1980, 88 or 87, whenever this was designed or built. And we got so many MOSFETs to choose from nowadays, it's not even funny. But we can replace these easy. I'm just going to pull out these rivets that I'm going to have to figure out a way to put a spacer in here and some bolts and washers. Just remove this. Okay. Now the next thing I want to do is see which of these MOSFETs are gone kaput. So we're going to check between source and drain. So here's this one. That one might be turned on. That one looks shorted. This one is open. That one looks open. There's a diode in there. I was measuring that diode. Yep. This one I don't measure a diode. Why? It burned out? No diode on that one. And this one's a dead short. Okay, so this one's good. If I turn the device on, voltage goes down. But if I turn the device off, voltage goes up. Okay. Perfect, those two are working. This one is completely open. This one's completely shorted. So we got two bad MOSFETs out of 4. Don't know how that happened. Very rarely drive the car, and mostly just sits. So we're going to take all these off, and we're going to replace them all with modern devices. Looks like the thermal connection wasn't too great. I glued it on with something. Looks like they just riveted them in place and then. Okay. That one. Okay. Good. Clean this off, and we'll select some new devices. Okay, another thing I'm doing is I removed these 3 electrolytics and tested them. They seem fine, but they're 85C rated and they survived this long. But these are Mashishita. You can see that if it's pretty tiny. So I'm going to replace them anyways. I got Nichicons here. And these are 105C rated caps, and quite a bit smaller too. The size difference between the two. So we're going to put these in. Like I said, it's totally not necessary because the old ones tested fine, but I'm going to do it because, you know, while I'm in here, I can do this stuff. And let's see. Oh, this conformal coating is really jacking me around. Just scrape some of it off. Just remember which way the positive goes. That's better, I think. holes are so tiny they just barely fits. Okay, I got that one. And this one here. There we go. I'll solder these 3 in. Everything looks good so far. Oops. That is a solder bridge. Okay, let me finish this and oops, let me finish this and then I'll okay. A little bit of wick right here. Cap fell out, of course. Ooh. Damn it. I lifted the trace. Alright, I'll have to give that a flux clean and get a good inspection on it. But that's going to be it for that. I also have a cracked solder here on this one connector pin. Free flow this. Might as well do all of them while I'm here. Okay. Another thing I did is I took the solder wick, cleaned off the pads for the MOSFETs, just so that we can push our pins through. And be careful of this. Don't want to break those leads. They're pretty flexible. And I want to clean some of this crap off because it's impeding the holes. So probably want to get a little Dremel and just I'll just clean this off right where the holes are and get this board ready for reassembly. Okay, so what I did for the BUZ71A, I selected an STF40NF03. So this is a 40 amp TO220 N-channel MOSFET rated at 30 volts instead of 50, which shouldn't matter. We're on an automotive setting, so it doesn't go over 15. 18 milliohms as compared to 120 milliohms on the other device. So this one should work really well, 40 amp, and I selected 4 of them. So I'm going to test these, test all 4 of them, and we'll check and make sure they are 100% before we put them in. Alright, so I got my 4 new MOSFETs are installed just to test fit, and I'm trying to determine what I need here for hardware, because the way it was before, we had this aluminum spacer that was riveted to the board and riveted to the heatsink through the transistor, and it was clamping everything together. So let's assemble something. I'm gonna get an M3 screw, machine screw. I think this is probably about I don't know how long this is. Let me see if I can figure out how long this is. This is about just under 20 millimeters, 19 millimeters. So I'm going to get a flat washer on here, then through the fiberglass board, and then I'm going to put my another flat washer to protect the board. Should pick better hardware, it would be. Okay. Now I have a tubular spacer that goes on, and then I'm going to put my device through this, and that's how it's going to look, like that. The device is going to be there, and then on top goes the sword, or the heat sink. Pretty sure it goes like this. And then a nut. And what I'm going to use is I'm going to use nylon self-lock nuts. Okay. So that whole thing should be, and I quite don't have enough length in my screw to make it. I might have to adjust get a longer screw like this, but that's the plan. Sandwich those things in between. I'm going to obviously goop up the back of these with heatsink compound. I'm kind of torn whether I should use a thermal epoxy or just a thermal paste, just to get it. See, there's some corrosion on these spots here, so I hit it with a scouring pad. Some corrosion happening underneath these transistors. Maybe that's why it gave up, because it lost its thermal conductivity and then it overheated, but who knows. So I'm going to get some more hardware here. I'm going to get some longer screws, and then we'll assemble this all together. And then, okay, this is what it looks like with the hardware installed. I got the washers, the spacer, and the transistor up in the air, and I got all 4 of those built up. So now, nothing's soldered yet. I'm not going to solder the backs until everything's mechanically secured. So now we're going to spread our paste. I think I'm just going to go with thermal paste. I'm just going to spread it on each device. Get a good coat. And then we'll secure down the heatsink. That's good. If we ever have problems in the future, I can always remove these and replace them. As if I put down a thermal epoxy, it's going to be bonded there for eternity, and might not be able to separate the two again. Probably would be able to, but it just makes life easier if you don't have to. Okay, so we got these 4. I'm going to put a little bit on this temperature sensor here. Not that it's needed, but okay. Now we put down our heatsink. So this side goes this way. I hope I have long enough screws here. Oh, look at that, it fell right into place. Let's put our nuts on. These are nylon lock nuts, so we don't have to worry about them coming loose ever. Okay, I need one more. This one is not long enough. I'll have to change the screw because it's not long enough. But you get the idea. Alright, there it is. It's all bolted together, tightened down, and that's what it looks like from the side. The spacers, the washers, the screws. Main thing is having a thermal contact between the aluminum and the device, and it's got to be secure here too. So these are all unsoldered, so the last step is solder this up. Let's just do that right now. Okay, so those are all in circuit now. And essentially this is finished, but we want to protect this, so we're going to have to figure out a way to, we'll do it what the factory did. Just give me a minute. Clean this up, clean up the flux, and then I'll be right back. Okay, so what they did at the factory is they sealed the leads. You know, you see a big blob of epoxy that was stuck in there, and then they put a blob over top here to protect the solder joints. Now, what they did is they injected it through these holes. So what I'm going to do is I'm going to inject some silicone in this hole, and it's going to come out the other side and protect those leads. I'm just worried about moisture getting in, so let's do this. I got to get this lined up with the hole. Can you see that? And then just start cranking. And I don't know if you can see that, but we're going to crank this till we get a nice blob inside there, and then I'll just leave it at that. Let's do this one. Okay, so here we go. Just put enough in there just to cover the leads and protect the device. Let's see if I can get this. I don't know if you can see this on camera though. So here we go. I'll clean that up the outside after. Oops. Okay. All right. So clean this up. You don't want any big blobs of silicone that can break loose and go into the system. Okay. Good. Now I'm just going to protect these with some more silicone and cover these up. If we ever need to remove them, we can remove them. Can clean the silicone off. Just blob this stuff on. It's a mess. Okay. We'll let that set up and we're done. Okay, so just to test this thing, I'm going to just plug it in. Plug it in and we'll just power it up and see if it... Let's see if I can do this one-handed. Yeah. Okay, so it's plugged in and I'm just going to leave it out in the open here. It's going to get hot, but there's no air circulation, no airflow over it, so it might get hot, but I won't do it for very long. So we're just going to turn it on and try it out. Alright, so keys in, let's turn it on. So far so good. Got no fan, let's turn it on. And we got nothing. Get my keys on. I think I have to have the other controller in place, and I don't. But the fan's not going on full speed, so that's a good sign. That tells me that it is no longer shorted. Okay, so let's go focus on the other module. Okay, so here's the other module. This is the main module. This is the IHKA This is one that has all the brains behind it. I took the liberty to open it up already. It's a plastic cover, and then you got a nice pretty circuit board. So this has a CPU on it, ROM, memory, driver transistors for motor controlling, and got some onboard voltage regulation, looks like. Not much going on here. Everything's conformal coated. A lot of heat here on this, on these driver chips. And it looks like somebody's probably me, probably came in here and resoldered these connections because they were baked. Everything else is looking good though. Very high quality constructed, double-sided board with plated through holes. So essentially you won't see a cracked board solder trace. Maybe you will. I don't know. I don't think you will. Let me see here. Where is my lens? So I'll look at some of these. Some of those connections are cracked around those resistors, and they've been resoldered on the other side. So I don't think there's anything wrong with this. I think it's working fine. Actually, this is the right way up. But one thing I want to do is there's a 220 microfarad cap here, and another cap. What is this one? 100 microfarad, 100 and 220. So I may replace these two. The rest of them are film caps, tantalums, and I think that's it. So we got the iron warmed up. Let's pull this one out, and we'll check it. This thing was, what's the date code on this thing? I think it's 1988. Let me see here. Where did I see a date? There's a date stamp here. No, that's not it. 1988 on this regulator. 88, 88, 88, 88. So this was built mid-88. The car is 1989 model year, so this makes sense. Built 1988. Yeah, so let's get this cap out and have a check it. So how old is that cap now? It's going on 45 years. You get lots of heat on here. There we go. So these are I think, what brand are these? EDE or something? And it's got puffy on top. That's why I'm kind of concerned. So let's try this out. Where's positive? Positive there. That's negative, I think. Positive. Okay. So it's doing not too bad for a capacitor that's supposed to be 220 at 40 volts. It's showing 226 microfarad and 360 milliohms. But the milliohms should be half that range. So I'm going to replace this one. I don't know what temperature rating this cap is. We'll put a new one in. Why not? We can do it. Okay, I'll take this 100 out. 100 at 25 volts. Let's take this one out. We'll replace this one as well. One of those things we'll do while we're in here. We'll do it. I don't know what temperature rating this is. And this measures 97. It's cooling off. It's dropping. 97 microfarad and 750 or so ESR. Yeah, the ESR is double what it should be. Actually, ESR is going up as it cools. It's over 800 now, 800 milliohms. Replace this one as well with a high temperature cap. Okay, clean the holes out, and I selected a 100 microfarad 25 volt. That is for the small one. That's positive here. Put this one in place. And for the 220, I selected a 220 at 35, 105 degrees C. This one goes up here. Okay. I don't expect this will make any difference in its operation. I just want to replace the capacitors here while I've got a chance. They get pretty old. Double-sided boards, you got to heat longer. The heat has to penetrate through the board to the other side so that the whole joint goes fluid. And then we'll just snip off the excess here. Okay, those two caps are in. Probably what I'll do is blob some silicone here just to secure them, because we are in an automotive application where things can get vibration. And what I'll use is just plain old silicone. I'm just going to pump it in here so it kind of surrounds them. There, that should hold them. Let that set up. This thing can go back in. Alright, put this back together. Snap together, and 4 screws, and we're done. Okay, here it is with the sword reinstalled, and there's the date code. I remember seeing a date code, 2188. The green plug is plugged into it. It's screwed back into the housing, and the other module is slipped in behind it. It sits in a kind of like a slot, and then it clicks in. And then you got 2 connectors, a blue one on top and a yellow one on bottom. They both got to be pushed in. So everything's good on this side. Okay, so I have now everything connected. Let's turn on the ignition. don't know if you can hear that. Okay, turning it on. I think I might have some stepper motors that are bad. I've got full control. Blower's working. Got full control of speed. Now I just got to make sure this is on auto. That's working. Seems to be working. Put it on the floor. Seems to be working. Okay. On the vents, defrost vents. And yeah, it's coming out the top now. And that switch is not latching. There we go. Alright, looks like it's all working now. I just got to figure out what else is wrong with this thing. Sorry, heat control. Okay, I'm gonna take this for a cruise and see how the heating and cooling's going. Still have some problems. It's making some popping noises and banging, but at least it's working now to the point where I can drive the car. Alright, take care. Thanks for watching. We'll see you on the next one.